All right, so we're going to talk about some square root functions, and we're going to talk about the domain of a square root function. Now, now a function is just anything that can be written in terms of one single variable. So I could have this. I could have y is equal to the square root of x. Now, if I think about what values I could put under this radical, under that square root sign, I know that I can only put anything that's non-negative. So the thing here is, and this expression under the radical, this is our radicand. The radicand must be greater than or equal to 0. If it's less than 0, I can't evaluate a square root and have it be a real value. It wouldn't be that. So in this, I could say, for this one, I could say, oh, my domain is x is greater than or equal to 0. Or if I were to write this in terms of interval notation, this would be 0 all the way up to infinity. So this is whatever we're doing here, we're always looking at this square root symbol. So let's do this again. When I'm looking at things that are maybe a little bit more complex, say I've got something like, oh, say I've got f of x is equal to the square root of x plus 3. Well, once again, I'm just setting this radicand greater than or equal to 0. So here I would say x plus 3 has got to be greater than or equal to 0. And, well, I can solve that, just subtract 3 from both sides. X would have to be greater than or equal to negative 3. Or since 3 is my lower endpoint, this would look like negative 3 all the way up to infinity. And this is this is with our inequality notation. This is with our interval notation. Now, and I could see this. If I wanted to, I could check our answers. Say I checked, oh, if I did, oh, x equals 1. Okay, f of 1 would equal square root of 1 plus 3. It's a square root of 4. I even have an answer for that one. That's 2. Whereas if I tried to go outside that, say I said f of negative 4. That's going to be the square root of negative 4 plus 3. That would be the square root of negative 1, and sure enough, that's not real. So this is not going to be part of our domain. So here, our domain is x is greater than or equal to negative 3. Now, there's a couple little subtle things that you should pay attention to with this. If you're looking for it, you're going to see things like square root of, let's say, 5 minus x. And here, this is something where, once again, we're going to set that radicand is greater than or equal to 0. But remember that when you dividing by a negative switches the direction of your inequality. So I could subtract 5 from both sides and end up with negative x is greater than or equal to negative 5, divide both sides by negative 1, and I'd end up with x would be less than or equal to 5. So when I divide by that negative 1, this switches the direction of my inequality here. So this is that 5 is my highest point. Or I could say that this would be from negative infinity all the way up to 5. And these are our domain. One other thing that can be, it's just something to pay attention to in the notation. If you were to see something that looked a little bit like, oh, so we had like y is equal to the square root of x minus 3. Sometimes it's not always clear where that radical ends. So here, only the x is under the radical. Only that x is the radicand. So this is still, x has got to be greater than or equal to 0. And that's our domain. The -3, this has to do more with the range. This is going to affect this is going to affect the range, the y value, more than anything. So watch what is under the radical. And what isn't. Alrighty, that's all I've got for now, and I'll catch you in the next video.